Okay, hopefully we can wrap up Summer Review 3 here if we have enough time. Now these, again, I wrote over here, this is kind of the result. You'll get problems that look like this, and you may say, well, why did I have this minus, this negative 2x? Why did I cancel these two and combine? Well, because this is actually, and you can go back and take a look at this again if you keep it on your computer. It'd be good to keep this on your computer, because when we get into the multiplication rule, when we take derivatives, you're going to see a problem that looks like this on the very first step. In other words, you'll apply what we call the multiplication rule for derivatives, and we end up with an answer that looks, with a solution that looks just like this. But then when you go to check your answer, the answer won't look like this. It'll be in a different form, so that's where you have to use least powers. So kind of keep this video, and then when we do the multiplication rule, you'll see. Okay, you'll say, oh, now I know why this makes sense. Okay, so first of all, we'll simplify this. So the 2's that cancel, I can take the x out in front. So this is basically the raw form, and then this would be the next step you would do. You would put the minus in front, cancel the 2's, and make that x cubed. And then again, you look over here, now I've got some least powers. First of all, I got an x in both terms, and I have this 1 minus x squared, and my negative 1/2 is the least power, so I'm going to factor out x and that. And then I showed you the division method that we use, so you could see, so I'm factoring the x out, so I'm going to divide this by x. And then this is my least power, negative 1/2, so I'm going to subtract. So this is going to be negative 1/2 minus negative 1/2. And this is going to be 1 minus x squared to the 1/2 minus negative 1/2. Okay? So this is going to be a negative. X goes in there, x squared times. And negative 1/2 and negative 1/2 is positive, so that's going to be negative 1/2 plus 1/2, which will be 0. So again, this comes down. And this is just negative x squared, and that's just 0. X goes into x1, so that leaves me with a 2. And then again, negative 1/2 plus, 1/2 plus 1/2 is 2/2, which is 1. So that's what we have here. So if that makes sense, got all the steps there. Now this stays the same, or I could put it in the denominator. I guess I waited one more step to put it in the denominator. Now this is just 1, isn't it? Anything to the 0 power is 1, so I just have negative x squared. So that goes here. And then this becomes, now this is just 1 minus x squared, but if I multiply by 2, I've got 2 minus 2x squared. So that's where this came from. 2 times 1 is 2 minus 2x squared. Okay. And then we could simplify this. This is 2, and then a negative x squared and negative 2x squared is negative 3x squared. So this is what we have here. This is the x. And then we can bring this down the bottom. So I can leave this x on the top, but I can put this factor on the bottom as 1 minus x squared to the positive 1/2. And as I said on one of the other problems, if you have 1/2, that's always the same thing as the square root. So for some reason, we have this in radical form. So this is how this simplifies out. So if you were applying the multiplication rule of derivatives to a particular problem, you would get an answer that starts out looking like this. And then that would be your first step, and you say, okay, I look in the answer book, or I look in the back of the book, and this is the answer I see, and I say, oh my gosh, did I get it right? Well, I have to go through all of this algebra to tidy this answer up into this little compact form, which is a lot more compact and neater to work, or easier to work with than this. So that's what this is all about. This is why we use least powers. Okay, let's take a look at number 15. And now we have a fraction, and this is actually going to be the result of what we call the division rule. And I kind of looked at this, and I could see what the original problem was. I didn't want to give you that because that might be a little confusing, but we may give it to you when we talk about these rules and have you refer back to this video. Okay? But this will be the first step after you apply the division rule to a particular function. This will be the derivative. But again, you wouldn't see the answer like this, so you have to simplify this. And again, this happens a lot, where we have these terms that are off by 1, a power of 1. And in this case, we've got 2 different common factors. We've got x squared plus 5, x squared plus 5, and x plus 3, x plus 3. So kind of like that problem we did earlier, except now we've got this fraction. So this is going to look a little bit more involved. So you need a lot of space. Okay? You might say, gee, how did you get that line so straight? I used a ruler. Okay, all right, so this is what we got. So my least power here, I've got 1/2 and negative 1/2, so that's going to be negative 1/2, x squared plus 5 to the negative 1/2. I've got 3 and 4, so my least power will be 3. So those are the ones that I factor out. So I've got a 4 that stays there, x squared plus 5 to the 1/2 minus negative 1/2, and x plus 3 to the 3 minus 3. There's my negative sign. The x stays there. I've got x plus 3 to the 4 minus 3, and I got x squared plus 5 to the negative 1/2 minus negative 1/2. And all over this x squared plus 5. Okay, so this stays the same, that stays the same. Negative 1/2 plus 1/2 is 1. And then 3 minus 3 is 0. 4 minus 3 is 1. And then negative 1/2 plus 1/2 is 0. So you see we get our zeros and our ones. Now I can put this in the bottom, so I chose to do that. So I got x squared plus 5 to the 1/2 times x squared plus 5, actually the first power. This is my x plus 3 cubed. And now this is just 1, and this is just x squared plus 5, so I got to multiply that by 4. So I got 4 times x squared plus 4 times 5 is 20. And this is just 1 again, so this is x plus 3, but I'm multiplying by a negative x, so I got negative x squared, negative 3x. Okay. And then all I have to do is simplify this, and I can combine these. 1 plus 1/2 is 3/2. So that's going to be x squared plus 5 to the 3/2 in the bottom. The x plus 3 cubed stays in the top. And then I've got 4x squared minus 1x squared is 3x squared minus 3x plus 20. So there's your final form. So that's what you would see in the answer. Okay. And the last one, number 16. See if we can get this on here.